Students, today we are going to discuss some practice problem based on integration. These problems are based on zero type of integration. So first question is 1 upon under root of x plus under root of x plus 1. So as we know that in this type we don't know any technique of integration or any formula for integration. We are just using the formula of differentiation in reverse order. So and basic techniques of mathematics are used here. So first of all we will rationalize this to simplify the denominator. So after rationalization it becomes x minus in the bracket x plus 1, so that it is minus 1 and minus can be adjusted in numerator, so that it is under root of x plus 1 minus root x, so it can be integrated with the help of power rule. So plus c. Next is 1 plus x upon under root of into 1 plus x multiplied by under root of 1 minus x. So students, here we should keep this thing in mind that we have to create this value which is under the root outside the root, so that I am writing 1 as 2 minus 1 and I am taking minus common, so it is 1 minus x. Now I am multiplying this under root 1 minus x with 2 as well as with 1 minus x, so that it is 2 root 1 minus x minus 1 minus x raised to the power 3 by 2. Finally we can integrate this using power rule. Important thing is that when you are integrating this with power rule, remember to write down this minus 1, which is the derivative of 1 minus x. So same it is here. Next is similar question, x root 5x minus 3. So again we will create 5x minus 3 outside the root by multiplying divide by 5 and adding subtracting 3. So that again opening the bracket we will be having 5x minus 3 raised to the power 3 by 2 and 5x minus 3 raised to the power half, which can be integrated with the help of power rule. But again remember that write down this 5, which is derivative of 5x minus 3. Next question is secant square x upon cosecant square x. So this is basically an illusion. If I convert this into sine and cos, so it is sine square x by cos square x, which is tan square x, and using 10th class identity we can write tan square x as secant square x minus 1. So secant square x is integral is tan x, because derivative of tan x is secant square x, and integral of 1 is x plus c. Now next question is 1 minus sin x whole upon cos square x. So first thing which immediately comes in our mind, that divide this, which is 1 by cos square x minus sin x by cos square x, splitting the fraction. So I am getting secant square x, which is again easy to integrate, and secant x tan x, its integral is secant x, so it is done. Some similar questions are there which can be easily integrated using the above question. So you can try this at home. Next question is integral of sine 4x upon cos 2x. Immediate thing which can be which can be thought using this after watching this question is we can apply sine 2 theta formula here. Now sine 2 theta is 2 sine theta cos theta, and in denominator there is cos 2x, which can be cancelled, so that sine 2x can be easily integrated by minus cos 2x upon 2. Remember to write this 2 because derivative angle is 2x and its derivative is 2. Next is secant square x into cosecant square x. Now this question can be integrated in two ways. First, let us convert this into sine and cos, and then multiply divide by 4, so that 4 in denominator can be written as 2 square, and it is 2 sin x cos x, so sine 2 theta, so it is sine square 2x. Finally 1 by sine square is cosecant square 2x, cosecant square integral is minus cot 2x upon 2, so it is done. Second way is again starting is similar. It is 1 by cos square x into sine square x, and 1 can be written as cos square x plus sine square x, so it is we can split this fraction, and by chance it is again cosecant square x and secant square x, but with positive sign in between, so that integral is very easy, minus cot x plus tan x plus c. Now next question is very interesting and very common, under root of 1 plus cos 2x. This expression is very common. We have done this in trigonometric function identity. This can be written as 2 cos square x. 1 plus cos 2 theta is 2 cos square x. So root 2 can be taken taken outside the integral, and cos square x is under root is there, so it is cos x. So integral of cos x is sin x plus c. Similarly, we can try this quotient is 1 minus cos 2x. So minus sign will give you 2 sin square x here. Instead of cos square x, we will be having sin square x. So we can try this question also. So next is under root of 1 plus sin 2x. Students, we know the formula for 1 plus cos 2x, but we don't have direct formula for 1 plus sin 2x. So what we are going to do, I am writing 1 as cos square x plus sin square x and sin 2x as 2 sin x cos x. If I am having sin x only here, so I will write 1 as cos square x by 2 plus sin square x by 2, so that it will become cos x by 2 plus sin x by 2 whole square. It depends upon me that what angle is given, and I can write the value of 1 as that. So we can write this as cos x by 2 plus sin x by 2 whole square, which can be done. So whether it is sin x or sin 2x, we can handle this question. Now another method of handling this question is that we can convert sin 2x as cos 90 minus 2x, so that it is similar situation of this question. So we can handle this by writing 1 plus cos 2 theta formula. Remember, angle is pi by 2 minus x, so angle will be pi by 4 minus x, that means half of that. So after that it's very easy. 2 can be written as outside, which is root 2, and cos square x can be written as cos x, as root is there. So its integration is sin pi by 4 minus x upon minus 1 due to derivative of pi by 4 minus x. So this will be written as minus 1 in the denominator. Next question is 1 upon 1 plus sin x. So again we can multiply, divide this by 1 minus sin x. So denominator is 1 minus sin square x, and after that we can proceed like the question which we have done above. We have done same question here, so we can do these steps again, so that this question can be done in similar manner. So I am leaving it here. After that, similar question, sin x upon 1 plus sin x, I am adding 1 and subtracting 1, so that 1 plus sin x is divided, so it is cancelled and giving result 1, and other integral is immediately the question which we have done, so it is same. So you can complete this question in same manner. So that's it. That's all for today. Take care. Have a nice day. Thank you.